product rule, if given two things multiplying together, we keep left differentiate right plus keep right differentiate left. It is okay if you flip it the other way around, where you want to keep right first then differentiate left, then plus keep left differentiate right. That's also fine. Because it's addition over here, it doesn't affect your answer. Okay? I want us to take a look at exercise 12.3, question 6. Okay? Correct me if I'm wrong, I last stopped at question 3, right? Okay, correct, thank you. Question. We are given the equation of a curve y equals to x minus 1 cubed times x plus 1. Question wants us to calculate the gradient of the curve at each of the points where the curve intersects the x-axis. Okay? So in this case, since I'm trying to find the gradient, I need to differentiate first. And the thing to differentiate is the equation of the function. Okay, and what will we get in this differentiation? Josh, how do we differentiate this? Yes, Josh? What will I write? X minus 1. Then to the power of 3 followed by say again 1, okay, and then sorry x minus 1 is it? What does that mean? X minus 1. Is it you say x minus 1? X minus 3. Yeah, okay, tell me what to write. Plus 1. What comes next? X minus 1 plus then followed by 3x 3 times x minus 1 to the power of 3. 2. Like that? This is what you want me, right? Okay. Alright, let's see. Okay, so in our product rule, we keep the left side, differentiate the right side. Differentiating x plus 1 does give us 1. Okay, then after we keep the right side, which is x plus 1. Differentiate the left, we bring down the 3. Okay, then we have x minus 1 to the power of 2. Alright, so if you want to have the 3, please put brackets around here, that's fine as well. Okay, don't have a standalone 3 in between. Okay, then after we proceed with simplification, x minus 1 to the power of 3 plus 3, x plus 1, x minus 1 bracket square. Okay, it is perfectly fine if you want to leave your answer like this. I know some of you were concerned about factorizing. So if you really want to factorize, what we see as common terms will be x minus 1 squared. Okay, what will be left over here is x minus plus 3 bracket x plus 1. Okay, then we can simplify it. And we get 4x plus 2. Okay, if you really want to factorize out the 2, no one's stopping you. Okay, so if you really want it to be fully factorized, you will, okay, looking like this. Okay, but there is really no need for us to do that, because what does the question really want us to find? The question wants us to find the gradient. Okay, to find the gradient value itself, we need to know what is the x value to substitute into my dy over dx. So keeping it at this stage is good enough. Okay, if you go into this and you end up being wrong, okay, you're just killing yourself lah, okay? So keeping it like that will be really much better. Okay, then move on to the next step of the question. Question wants us to find the gradient where it intersects the x-axis. So that means that when y equals to 0, because that is where the curve intersects with the x-axis, so we are trying to solve this when it is equals to 0. And that will give us x values. And what will the x values be? Xingxuan, what will the x values be? Negative 1. Anything else? Or is it just this? And positive 1. Okay, so when these two multiply each other to give us 0, it either means that this thing here equals to 0 or this thing equals to 0. So x minus 1 equals to 0. Or x plus 1 equals to 0. That's why x equals to 1 or x equals to negative 1. Okay? Just trying to be clear for those that don't quite see it yet. So with these two x values, we find the gradient. So we can use this answer here, the product, after the product rule, okay, to find out what is the gradient. That will be equals to 1 minus 1 cubed plus 3, 1 plus 1, 1 minus 1, which essentially is 0. Okay. And then when x equals to negative 1, we find the gradient. And key that in into our calculator, we should get negative 8. Okay, so we got two gradient values because the curve will intersect at 2 points. Right, and those will be the gradient values that we have. Yeah. Okay. Can you ask, are we supposed to substitute this into dy over dx or sub it into the original y? Okay, you have to think back, what does the question want us to find? The question says calculate the gradient. We are only able to find the gradient through using our dy over dx. Okay, that's why we need to take x equals to 1, put it inside our dy over dx. You understand? Okay, if you put your x back into y, right, you're only going to find the y coordinate, which actually should be 0. Yeah, because this x came from this y to 0. Yeah, still a bit confused. What is it that you still don't get? The dy over dx don't have cube. Then there's a cube here. Because I use this one, I didn't use this one. Yeah. Okay. Because I I want to show that this is already good enough as an answer. No need for us to use the rest. Okay. Right? Any questions? Okay. Let's move on. Question for product rule. Okay, so we are given the curve y equals to x squared minus 1 over x squared plus 1. We want to find the y coordinate of the point where the differentiation, the derivative is equals to 0. In other words, the gradient equals to 0. Okay, we will learn more when we go into chapter, I think 15, 16, 17, somewhere there. Okay, what does dy over dx equals to 0 imply? Okay, so we'll go into that later on. Now, at this point, we only know how to do chain rule, power rule, and product rule. Okay, we have not yet learned quotient rule, which is coming up after I do this question. Okay, so I want us to learn an alternative, okay, to quotient rule. What if I use our product rule instead? Okay, so in this case, it is a quotient because it's a fraction. Okay, later on, maybe when you see quotient rule, you understand it better. Alright, but at this stage, we want the skills that we have. Okay, x squared minus 1 over x squared plus 1 is the same as writing x squared minus 1. Bring the x squared plus 1 up into the numerator. That means x squared plus 1 to the power of negative 1. Okay, so we can see this fraction we express into this form, which is a product of two things. Okay, then we can do our differentiation using product rule, whereby we keep left, differentiate right, okay, plus we keep the right side, differentiate the left. Okay, don't have enough space, so I'm writing at the bottom. Okay. Right? You may want to go about simplifying this before we go into finding out the answer to the question. Okay, so we can tidy things up a little. I'm writing it as x squared or negative 2x squared minus 1. Denominator has our x squared plus 1 to the power of 2 plus 2x over x squared plus 1. Okay. So by tidying up into this extent, it's really good enough already. No need to make the denominator the same. Okay. Next, we want to find the y coordinate where dy over dx equals to 0. So the question has told us that dy over dx equals to 0. That means that negative 2x squared minus 1 over bracket x squared plus 1 squared plus this is equals to 0. Okay? This is where we need to know how to solve this equation. Okay? Now, what will your choice be in your next step? How will you solve this equation? Vanessa, what do you think? How will you solve this equation? Make the denominator the same. Okay, how many of you would choose to make the denominator the same? Okay, alright. Then the rest then? Only see like 2 hands. So what will you do? You see, you look like you have something in your mind. What will you do? No idea how to solve. Other than making denominator the same, what else can we do? This is equals to 0, right? Okay. You can just multiply across by the biggest denominator. That's also possible. But since Vanessa proposed to make the denominator the same, so why not let's do that? Okay. So that will actually mean that I need an extra x squared plus 1 over here, so that I can have a square. So my 2x I also need to multiply with x squared plus 1. Okay, so this is how we make the denominator the same, huh? Right? Okay, make the denominator the same already, then so what? Right? Denominator the same already. For fraction equals to something else, we can always do cross multiplication, remember? Okay, so denominator the same is same meaning as this, huh? This is the same thing. So remember, whenever we have a fraction, a single fraction, okay, a single fraction equals to another number or fraction or whatever, okay, so long as it's a single fraction also, we can cross multiply. So we take this cross multiply over, and what we will have is negative 2x x squared minus 1 plus 2x x squared plus 1 equals to 0. This one cross multiply over means 0 times this. So right hand side should still be 0. Okay? Right? At this juncture, what will you do next? Cheyenne, what do you think? What will you do? Don't have to give me a right answer. Yeah. Just give me something that you think you will do. Sorry? A what? A squared plus 2ab plus b squared. Is it? Sorry, I didn't catch what you're trying to say. You want to factorize this to a minus ba plus b, is it? A squared minus b squared, which is this one. So you want to write it like that. Like that. Is it? This is your a squared minus b squared. A plus b, a minus b. Is that what you would like to do? But is this helpful? This one and this one. What about it? You tell me what to write then. I erase this up. Expand. Okay, just expand. I think will expanding be what you think of doing? No? Maybe no? Then what will you do? Same thing as just now what I wrote now. Okay? I would think that the intuitive thing is to expand now. Okay? Alright? If you want to factorize this into this, right? Okay? I hope you realize that doing this thing itself, it is not very helpful, because what can I do with this information to move forward to find the value of x? Right? Not very helpful at all. Okay, so that's why the other plan that we might want to have is to expand it. Okay, and we get this. Right? Okay, and then we see that negative 2x cubed and 2x cubed cancels each other out. 2x plus 2x, I will get 4x equals to 0. X will be equals to 0. Okay? Alright? But then it's not yet the answer. Okay, because question asks for y coordinate, I only have x equals to 0. That means that I need to take this x coordinate, place it back into the curve. Okay, because the point is lying on the curve itself. So y coordinate will be -1. Okay. Any questions? Questions? No? Okay. Then that's it for product rule. Homework. Okay, 2.1, 2.2 I didn't give you homework. That one your own time, own target, go and do. But 4.3, there will be homework. Okay, question 2C, 2D, 3B, question 4, 8, 10, and 11. Alright, when shall this be due? Next year. Someone said next year. Okay, I'll be away from this classroom already. Thursday, but you got camp WA1. Next week, yeah. Then tomorrow, if I finish Quotient rule, the homework also due next week. Yeah. Then Monday, a lot of homework due. You're okay, yeah? Okay, you okay, I okay. Yeah. Then weekend, I'll just mark your AMAT WA1. Okay, well, that's all I have. Okay, then due Monday. 27 Feb. Okay? Yes. Okay, maybe I show it to us. Okay. Carrie has a question. I think it's worth thinking about it. Maybe I write it here. Okay. From this step, instead of making same denominator like what Vanessa suggested, okay, what Carrie has instead is 2x over x squared plus 1 equals to 2x squared minus 1 over x squared plus 1 squared. Then 2x squared minus 1 x squared plus 1 equals to 2x squared plus 1 squared. Okay. Okay. Shall we ponder about this part whereby Carrie is a little bit studied? Okay. What she did is that she brought this fraction over here to the right hand side. So we get this part. Nothing wrong with that. You agree with that, right? Okay. From this step to this step, nothing wrong. Alright? Then later on, okay, she knows that with a single fraction and a single fraction, we can cross multiply. So she cross multiply and arrive at this one. Also not a problem at all. Totally correct. Okay? The next step that she decided to do was to cancel the 2x and then cancel away x squared plus 1. Okay? So technically her next step will be x squared minus 1 equals to x squared plus 1. Then after that, what's the answer? Cancel again, right? Minus 1 equals to plus 1. And clearly we know that's not correct. Agree? So what went wrong? What went wrong? I addressed this in class before. The cancellation. What about the cancellation that's not correct? Sorry? Can be 0, very good. Okay? So we have addressed before that if I know that x, okay, can be 0, right? I cannot actually cancel like that because I cannot divide by 0. Because if x is equals to 0, we look at this fraction itself. Does it give us a value? It does give us a value. It gives us 0. Because the denominator is 1. Okay, I can get a proper fraction out of this. Likewise over here, if x is 0, this thing I can also evaluate out what is the number to it. Okay, so there is that possibility for x to be equals to 0. That's why we cannot, okay, cancel away unknowns. Alright, I cannot cancel away unknowns like this. 2x and 2x I cannot cancel. If it's just a value 2 and 2, I can cancel lah. But 2x and 2x I cannot cancel. You understand what I'm saying? Okay, because x can be equals to 0 or the thing itself can be equals to 0. That's why we never have the practice or the habit of cancelling away zeros. Because cancelling means division. Okay, I cannot divide by 0. It's not like I have a bag of sweets, I want to divide by 0 paper. Doesn't make sense, alright? Then what does that make out to? Okay, I just own all the sweets all. Okay. So that's why that's the problem over here. Okay? So I think this is a very good example to bring out and highlight about this idea of cancellation, which is not right. Okay? Are we clear about this? Okay, so then how? Okay, so I know that now, okay, maybe also to help Harry. Okay, even if up until this step is actually correct, just that I cannot cancel, then what should I actually get? Okay. Okay, at this stage then, how do I move on from it? Okay, it would be complicated because I would say that the next step moving forward is to really expand it. Okay, I don't see any other way if I cannot cancel away x squared plus 1. Okay, so the only way out is to really expand this. So x power 4 plus 2x squared plus 1 equals 2x. X power 4 plus x squared minus x squared minus 1. And then this will give us the power of 5, which is impossible for us to deal with at this level. This one cancels out. Minus 2x. Okay, so if we expand and simplify, we get this one. This one we will eliminate each other out. Okay, so if I want to really solve, I will get x equals to 0, which is the same as this one. Just a very, very long method. Okay? There is always a solution out of doing things, okay, in a different method. Just that you must know how to actually get out of that problem. Okay? Yes, Cheyenne? Sorry, repeat. Oh, okay. Okay, so Cheyenne also thought maybe you can factorize out 2x. Also okay, simplify does give us x equals to 0 as well. Okay, many ways of doing things. Right? Okay, so what is something that is more important is that your algebraic concepts are actually build a very strong foundation. Right? Which explains why, okay, it is going to be easy for me to tell you how to solve, okay, but that will be my way of solving. Right, but at the end of the day, what is it that you end up putting on your paper? Okay, you will give me a different way of doing things. Just like I give you all the quiz, Jasper give me quotient rule as his answer, okay, to the fraction one. Okay, then I haven't even teach quotient rule yet, and then give that to me as an answer. But that's perfectly fine. Okay, nothing wrong with that. Just that we must be certain with what we're doing. Okay. Alright, so let's move on, okay? Let's go into quotient rule. What time my lesson end? 1:20, right? Okay, I introduce the quotient rule. You all go and let it sink inside your brain first, okay? Quotient rule is much more complicated. Okay, quotient rule, we're talking about fraction. There is so-called an algebraic formula, if you want to put it that way, okay, in your textbook, but I don't really remember that formula also. I just remember the process. Okay, so the process for quotient rule is that you need to keep the bottom first, differentiate the top, minus away, keep the top, differentiate the bottom, divide by bottom square. Okay, very complicated. Okay, these are multiplication. Okay, so must always keep the bottom first. That means keep the bottom as the same thing. Okay, and then after that differentiate the top of the fraction. Okay, then we minus away the reverse. Keep the top, differentiate bottom. Then the bottom must square. Sorry, not differentiate, square. Okay, if you're talented enough, you can go and create a song out of this. I don't have that talent. Yeah. Chain rule, product rule, you mean? Yes, you can. Yeah. Okay. So Vanessa asked a good question. Can I just move the star up to numerator and then use product rule? You can. Nothing wrong. Okay, which is what I was doing just now. Okay, in the exercise 12.3 question 9. Right? I use my product rule. Okay, but I want us to be familiar with both. Okay, don't just solely rely on product rule. Right? Knowing quotient rule is still important. Okay. So I just show one example to show how it's being used. Okay, differentiate this one. So what we do is we keep the bottom 2x squared minus 1. We don't have to care about the indices. We just take 2x squared minus 1 on its own. Okay, don't have to care that it's actually negative 1. We don't do that. Just see this itself only. Differentiate the top, we get 4 minus away. Keep the top. Differentiate the bottom, that's 4x. Divide by bottom square. Okay? Then we can simplify. the quotient rule was being applied. Then after that, in terms of simplification, something to take note is that it is a minus sign outside here. Okay, you do your rainbow for your 4x and 4x as well as the 1. Remember to keep the brackets first. Okay, then after that, when you open up the brackets, it is a minus 16x squared and a minus 4x. Okay, so the simplification process, you need to take careful note about how the algebra works. Okay. Right. So then we continue to simplify and factorize out the negative form. Okay. So it really depends on what the question asks you to differentiate up to. Sometimes it may ask you to differentiate up to here. Otherwise, leaving it at this expanded form is perfectly fine. The denominator, you don't have to go and expand it. Okay, you can just keep it factorized. Okay? Please go back home, dream about this, let this sink into your brain. Okay, know the process. Then tomorrow we will continue with our quotient rule. Okay, thank you everyone, that's all for today.